Da-da-da. Okay. All right, so I get to actually do the lecture that I tried to start the other week because I picked the wrong lecture notes up. So now we're doing it properly. And I went back and looked. The piece that I couldn't remember was the crossover design. And so a crossover design means it's a repeated measures, but both groups do both levels of the IV. So if you've got an intervention and a control, or two interventions, then you have one intervention period and then they switch and they both do both sets. I don't know why I couldn't remember that at the time, but I couldn't, so. All right, so just to let you know, I don't have a lecture on qualitative data analysis, but there is a comprehensive handout up on Blackboard if your study turned out to be qualitative, all right? So I would download that, because once the semester's over and you're not in this class anymore, you won't have access to it. And then if you end up writing a thesis or doing a qualitative study in another class, you won't have the notes for it. So make sure that you get that downloaded or printed for yourself before you lose access to it. Otherwise you'll be chasing me for a copy of it, which is fine also, but it'll be much easier if you just have it. Okay, let's see, this wasn't working this afternoon, so let's see if it will work. All right. Okay, so we're going to look at a quantitative situation. So we've had a question, we've been out, we've collected data, and the data we have is numerical in form. Okay, so what do we do with it? All right. So we're going to back up just a little bit and think about the question first of all. So that's your purpose that we're doing right now. Okay, what is my burning question that I have to know the answer to? Okay, so the purpose of this study is to blah-de-blah-de-blah, right? So it's important that you identify the question first before you make the decision whether or not it's going to be a qualitative or a quantitative study. Some studies automatically fall into one or other of those categories. Some questions you could do either way, depending on what you really wanted to get at. Okay? So most of you have your question now. A couple of you have to tweak them for the next go-around, but you know, we're moving along with your question. If it's quantitative, then we want to look at how many levels of data do we have, what are the variables that I can identify, right? What kind of data do I end up with? And when we run a statistical analysis, because we're lucky enough now not to have to do those by hand, we do them through a software package, and there are piles of different software packages out there for data analysis. The one that I'm familiar with is SPSS, but there's lots of other different software packages for stats. When you press the button, even though you've asked it to do a particular type of analysis, you'll always get the first part of the feed out will be a descriptive set of data. So it'll tell you how many people are in the data set, it will tell you the mean of their ages if you gave it that information, it will tell you how many of them are male and how many of them are female if you gave it that information, right? So you get this quite useful descriptive data to begin with. and then you'll get the rest of the printout. Okay? When we're doing quantitative, we're usually looking for either differences between things or relationships between things. Right? So, brief reminder, because it was a couple of weeks ago, IV is an independent variable. The independent variable is the thing that I am manipulating in the study. The DV is the dependent variable, that's the variable of interest. Okay? So, how many independent and dependent variables do you have in your question? Now, I set a boundary on you because at the master's level we want to keep it as simple as possible. You should only have one independent variable and one dependent variable in your research question. All right? I'll go to 2 independent variables if you can give me a good argument why you need 2. But we're not having more than one dependent variable because that really complicates things, okay? So up on Blackboard, there is this cheat sheet which I got when I took stats in grad school from my statistical professor, and it saved my life. Between this and the APA manual and the SPSS Idiot's Guide to Stats, that's how I got through my research study. So, you want?
So that's hard?
Yes, yeah, everything's on Blackboard. This is useful because once you define your variables, you can use the cheat sheet to tell you which statistical analysis you have to run. So you can basically do this whole thing without knowing any stats, other than how to interpret the output, right? Because Tony and the software package do it for us, okay? So we have to define if our independent variable is continuous, right? So if it's continuous, that would be like I am running a distance and we're timing it, right? So time is continuous, okay? If it's, bless you, if it's categorical, then I'm looking at whether something is red or blue, or green, or yellow. Can be dichotomous, like sex is a dichotomous variable, male or female. Those are your choices, right? So, gender, whole different kettle of fish now, these days. Not when I was doing study, but sex is dichotomous, okay? So, same thing with the dependent variable. Is your dependent variable continuous or categorical? Once you've decided those, then you can look on the table on the cheat sheet and you can go, oh, okay, that's the statistical analysis I'm going to run, right? So you plug all your data into, it's like an Excel sheet in the software. And then you press run that test and it does it all for you. It's magic. Magic.
What's the definition of categorical?
Categorical means that you've got separate entities for this variable. So it could be high school, middle school, elementary school. Right? That would be categorical. All right? So that makes it really, really simple, and you can ignore the bottom part of that table because that goes into what you have to do if you've got multiple dependent variables. And that, as I said, that gets seriously complicated, so stay away from that as much as you can. All right, stick with 1 or 2 IVs, 1 DV. All right? So, let me see, do I want to go to the next page for that? No. All right, so descriptions of the statistical tests, I've scanned in from a different book, so this is up there as well. So these are the 3 documents that you want to get your hands on. So this appendix from a different textbook gives you the description of all the different statistical tests. Okay, that can be useful when you are reading the results section of any papers that you've pulled out. Right? If you're really trying to understand the statistics in a results section, you need to understand. You need to know what the stats are. So this is like an easy version. You don't have to go get a research book out of the library, although I would recommend that. Right? But that's just a kind of to-hand descriptive list for you of statistical analyses. Right? So, when I've got my independent variable, sometimes we have different levels of the same independent variable. And there are some tables in your book, in chapter 24, table 0.1 and 0.2, give you some examples of that. But it's pretty easy once you get the hang of it, but it is one of the errors that I often see in the final presentations. All right? So if I am going to look at, let's make it simple. We're going to look at strength, right? So strength increase is our dependent variable, right? And we're going to use 2 different types of training programs, okay? So training program is my independent variable. But I have 2 levels of that training program A and training program B. Right. So quite often what I see in the presentation at the end of the semester is, because there's a checklist for you, and one of the things on the checklist says you should identify your dependent variable and independent variable for your audience. Right? And quite often what I'll see is I have 1 DV and 2 IVs, training program A and training program B. But that is incorrect. You have 1 independent variable, but you have 2 levels of that independent variable. Right? We sub. Does that make sense?
No.
No?
You just confused me a little bit.
Okay. So if this is your study, right, it would be incorrect to say that I have 2 independent variables, right? Because you would say I have independent variable at training program A and I have independent variable training program B. But that's incorrect. You don't have 2. You have 1. Training program is the independent variable. That's the thing you're manipulating. Right? You have 2 levels of training program. Training program A and training program B. But the thing you're manipulating is training program. So that's your independent variable. Does that make it clearer? Okay. question really is, a lot of this is to help you read your papers, because many of you aren't going to run your own study and collect data, all right? And that's fine. We have that option and we have another option. You don't have to do that, okay? But when you're reading these papers, sometimes the language is difficult to understand, and so I'm just trying to give you a little bit of explanation of some of the language you might see when you're reading these research studies. So they'll often talk about the shape of the data or whether they have normative shaped data, right? So if it's a bell curve, then that means that your data looks like that. Pretend that's equal on both sides. Okay? So this would be normative, because if we have a large enough population, we expect there to be very few brilliant people, very few really thick people, and a ton of people who are in between, right? That's how genetics work, that's how everything works, really, right? So this is the typical picture if I have a large enough population and they're relatively well balanced and things like that, all right? So this would be normal data, right? Sometimes, though, that's not what we get, okay? Sometimes we get skewed data, all right? And data can be skewed negatively or positively. And so if my data looks like that, that's called a negative skew. Took me forever to get this straight in my head in grad school, because I assumed that the skewness was decided by where the bump was, but it isn't. The skewness is decided by where the long x-axis is, which direction it's pointing in, right? So this is pointing to the left, so that's a negative skew, okay? If my data does this, that's a positive skew, okay? And you'll see that term quite a lot in our kind of papers, in our kind of data, because they weren't able to balance the population well enough, or something happens, they're working outside and the weather changed, and so they got a load of funny data in the set, right? Things like that. So you'll quite often see the authors talk about the fact that the data was skewed positively or negatively. Therefore, they had to run an additional set of statistics on it, right? The other term, I have to say, honestly, in all my years of reading, I've never seen kurtosis used in a research paper that I've read. But I'll show you what it means so that if it crops up, you've at least got a picture. So kurtosis means that instead of having this nice kind of balanced curve, if it does this, right? Or it does this, okay? Instead of being like that. But as I said, I've never seen it in a paper, but I just want to make sure that you at least have heard the term before, so that if it crops up, you can go back and go, ooh, I have no idea what that was. Let me go back and dig in my notes and find it. Right? Okay. So more statistical verbiage, really. Again, you'll see often the terms we used a parametric statistical test X, or we used a non-parametric test Y because, right? So we use parametric statistical tests when we can safely make certain assumptions, right? So we can assume that the spread of our data is relatively equal, right? That the variance is equal across the spread of the data. And that we have this normal distribution, so our typical bell curve, right? If we make those assumptions, then we can use parametric statistical analyses, right? And I don't think at this point you need a list of what parametrical statistical analyses, which tests are parametric. You can go and look that up. There's some information in our textbook. There's plenty of research books in the library, or go online and Google parametric stats, and you'll get a list of tests, right? So I don't think that we need to worry about that right now, because unless you do a study, you're not going to need to write it. It's just you'll read it, so I want you to know what it means. Right? However, sometimes we can't make these assumptions, right? Sometimes we've looked at the data and it's clearly skewed, negative or positive, okay? And so when that happens, we can't use the first set of analyses that we would use, okay? We have to use some different ones, and we might have to do a pre-test first to reorganize the data before we run the straight analysis. So there's all kinds of jiggery-pokery that has to go on if you end up in this situation, right? At this point, we go over to the math department and get a statistician, because we're outside my realm of comfort, okay? So when we do this, it's because we're not normally distributed, so we're skewed, or we've got ketotic data, or the intervals are not equal in the data. Okay. I've seen more of this recently in more recent papers. I think that people are more statistically aware these days than they were 20 years ago, right? So 20 years ago, we just assumed that the data was normal, and we ran that analysis, right? I think people are cuter now, and so they're a little more careful to make sure. Also, the editorial board for journals, they generally will have someone who's maybe a little bit more statistically aware. And so if you do this, and they look at your data and go, naughty, naughty, we're rejecting it, send it back when you put it right, right? So I think that more and more, if you're reading more recent papers, that you'll come across this kind of terminology a little bit more than papers that were in the late 1900s or in the early 2000s. Okay. Table 24.2 gives you the kind of pre-test that you would do to find out what you're supposed to be running if you were doing it and being clever, right? Again, you don't need to know this. You just need to be able to access it if you're reading something that doesn't make sense to you, right? This is what it's all about. I'm not really trying to get you ready to run the study. I'm just trying to give you the lingo so that reading your research papers becomes a little less onerous and scary, right? Because you've got a lot of them to read over the next couple of years. So. Okay, so the hypothesis. Most papers you read, if they are quantitative, will talk to you about the hypothesis, and towards the end of the paper they will talk about whether or not they met the hypothesis or they met the null hypothesis. So just to give you some definitions and examples of what that means. So the research hypothesis is often labeled H1, is what you think might happen. So we go back to our strength training example. I think, based on the reading that I've done, that intervention A will make the athlete stronger than intervention B. And that it will be significantly stronger than intervention B. Right? The null hypothesis, HO, is the statement that there won't be any difference. So here we're going to say that A is the same as B. The results from intervention A are not significantly different than the results from intervention B. So that bit is relatively straightforward. Then comes the tricky verbiage, right? As researchers, of course, when you go into a study, what you're hoping to find, right, is a significant difference. That's what you want when you go in. So up front, we want to be able to reject this and accept this. But that doesn't always happen, right? So sometimes you'll get to the end of the paper and the authors will say, we are unable to reject the null hypothesis. We think maybe because, right? So if they can't reject the null hypothesis, that meant that they didn't find anything of significance. Now that can be important, right? Depends on your study. Okay. So do you mind if I use you as an example? So Danny's study is going to look at a particular athletic training technique that she prefers, called the Graston technique. And she's going to compare the results of using that technique with the results of cupping. Okay? So obviously going into the study, what she wants to find is that the Graston technique is significantly better for helping the athlete than the cupping technique, right? So that's her research hypothesis. Her null hypothesis, her statement of null hypothesis will be that Graston technique and cupping have no significant differences in outcome for the athlete. Right? That would be disappointing for her because she's bought into the Graston technique, and that's where she feels she can have the most impact on her athletes, right? But what I've tried to point out is this is not a bad end point for a piece of research, because if what you find is Graston and cupping are exactly the same, then that gives the athletic trainer flexibility to use the technique they prefer and they're most comfortable with. If what she finds is Graston technique is significantly better than cupping, everyone who's spent money and time and resources learning cupping is stuffed because now they've got to learn Graston technique because it's better, right? So she's in a win-win situation, really, because it doesn't matter whether she gets a difference or doesn't get a difference. It's a useful piece of research for the athletic training population. Does that make sense?
Yes.
Yeah. So, try to remember that research hypothesis is one is better than the other. Null hypothesis means they're both the same, and I want to reject the null hypothesis because I don't want them to be the same. Double negatives if you're an English major type person, right? Two negatives in the sentence makes a positive. So if I'm rejecting a not, then that. Okay, on to our alphas and p's. So some of you started picking up the p-value in your summaries before midterm. That's great. You should report the p-value in a summary. So be thinking about that for your annotated bibliographies. The probability of you finding a result, right, is called alpha, literally alpha, like the Greek. Right? And it's really important that alpha is set what we call a priori. That is ahead of collecting the data. And I can tell you categorically that some people cheat, right? And they collect the data and they run the stats and then they go, oh, I'm going to make my alpha something else now because it makes the study look better. That's cheating, right? Alpha has to be set before you collect the data. And it represents the fact that the results of the statistical analysis show the probability of finding if the null hypothesis is true. So we want it to be small because we don't want the null hypothesis to be true, right? We want to be able to reject the null hypothesis. Okay. So my p-value is, for our kind of study, p is usually less than 0.05. That means I have a 95% probability of being able to reject the null hypothesis. Sometimes you will see a p-value less than 0.01. That's great in our kind of work.
So you want the p-value to be less as possible.
Yeah, as small as possible, right? If they're reporting results where significance is p is less than 0.01, that's really nice data. They're very, very happy bunnies, right? In sociological studies, you'll quite often see p, or educational studies, you might see p at 0.1. You would never see that in a physical activity, sport, exercise science, coaching.
Okay, I have a question. How
Yeah.
we gonna find that p-value off of the stat sheet that you gave us?
No, it'll be in the articles as you're reading them. It'll be in the results section. The alpha should be in, if they've got sometimes there'll be a separate heading for data analysis, they might have it there. If they don't have that, it should be either at the beginning of the results section or at the end of the introduction.
Okay,
They'll tell you this info.
So if it's too high, then we should use the article, what you're saying?
If they're setting P at 0.1, you want to question the study in our field, right? If it's an education paper or a sociology paper, P.1, P less than 0.1 is fine, right? And here's why. Because the easiest way to explain it is if you make it about drugs, okay? So let's say I am testing a new drug and I set P at 0.1. That means I have a 10% chance of being wrong. Right? So I'm going to run this study to find out if this drug kills people or doesn't kill people. Is a 10% error acceptable? No. Right? So in drug-related research, in pharmaceutical research, you'll never see anything other than 0.01. Because now I'm 99% certain that my results are accurate. In our world, because we can hurt people if we do it wrong, right? We usually go to 0.05. That gives me a 95% chance of being right, if I find significance. So, yeah.
They help have you break it down. I was confused.
Yeah. Making it about drugs makes it much easier to realise the importance of the P. Right? So, if P is greater than the alpha you set, so if you set alpha at 5% and your P comes out at 0.061, you have to accept the null hypothesis. You don't have significant differences. Okay? If your P is less than or equal to your alpha, then you get to reject the null hypothesis. You found significant differences between your groups. Yay! And everybody's happy. Right?
Now, you want us to do this on our final project to find our P's and stuff?
No, because you won't have any data to run.
Okay.
So, but when you're writing your summary on your articles that you found, when you are reporting your results, you should report whether the results were significant, and if they were significant, what was the P level.
Okay.
If they weren't significant, what was the P level? Right? So you want to get into the habit of looking for that information in the results section. Sometimes it's easy, sometimes it's a bear to find. find that info. Just depends on the article and the amount of data they're reporting on. Right? Okay, so type 1, type 2 errors. Again, language that you will probably see during your time reading research. Type 1 error is really bad. It's really bad, right? So a type 1 error means I reject the null hypothesis when actually the null hypothesis was true. So let me go back to the drug example, right? If I use 0.01, right, and I state this, right, so I say that I did find a significant difference, right, and that isn't right, then, or I didn't find a significant difference, and I should have done. Here, I can accept the null hypothesis for a type 2 error when actually it's wrong. That's not so bad, because I'm less likely to kill someone with a type 2 error than I am with a type 1 error. It confuses me all the time. I'm not surprised. Okay, let me go back one. That's okay. You don't have to learn this stuff, right? This is not information that you're expected to learn. This is information that you need to know it exists, so that when you're reading the paper and you go, what the frick does that mean? Oh wait, Dr. Wall mentioned something about type 1 and type 2 errors. Let me go and look those up. Right? So my research hypothesis is that A is better than B. My null hypothesis is that A doesn't give me any significant differences. Okay? All right. Let's see if I can get this right. So, a type 1 error means that I reject this idea. Right? And I accept my research hypothesis. But this is true.
Well, I'm gonna publish that my research was right.
Yeah. Yeah.
Oh, okay. All
Right? So if we go back to the drug idea, we say, oh, the drug won't kill anybody. Right? But my null hypothesis was true, my drug will kill somebody. That's a pretty big error to make. Right? If I do a type 2 error, a type 2 error is the other way around. So a type 2 error means that I say I found no significant difference when actually there was a significant difference. Which is annoying, right? But it's safer. Does that make sense? As I say, don't try to learn this idea. As you can see, I still have to scribble it out because I haven't been doing a lot of research for the last few years. And if you're not using it all the time, it poofs away. So don't expect to remember it. Just remember that you've got some notes on it and you can go back and look it up if you need to. Right? The higher the power in your study, the less chance you've got of making a type 2 error. Often power seems to be tied to the number of participants that you have in the study. So if you only have 2, you might not find significant results, but that might be because you didn't have enough power to find any significance. You might need 200 participants to have enough power. Right? So again, you often will see the authors talk about this term power, or we didn't find, in their discussion, when they're trying to explain what they did or didn't find. Then they might say, oh, we didn't have enough power. We still believe that there's a trend towards significance in the data, but there wasn't enough power to find significance.
So you're saying power is the participants?
It's related to the number of participants, often. It isn't the only thing, but that's the easiest thing to link it to when you're not really a stats person. Right? But again, it's the verbiage that's important. You're going to see them use these words, particularly in their discussions, because the discussion is the fun bit. The discussion is the bit where I get to talk about what I found and why I think I found it, or why I didn't find what I expected to find. Right? And so these terms will start to crop up when you're reading the papers thoroughly. You know, when you're skimming, you often miss these terms, right? But when you start reading them carefully, you'll see these more often. So they might report the effect size that they found. They might report R or R squared as effect sizes. Less than 0.2 is considered a small effect size. So here's the interesting thing. The effect size is the key when you are a hands-on, practical, applied person, right? Because I can find significance, right? So I can genuinely report that P was less than 0.05 and not lie, not twist my statistics or my data, and my effect size is 0.1. So that means I have a significant difference that's practically no use whatsoever. Right? Or I can have a significant difference and have an effect size of 0.9, and then I'm like, oh yes, because now I have a significant difference that actually means something. Right? So that's another clue to the papers when you're reading them, because often authors will leave out reporting effect size, and they'll report the significance and the P because they've got significance and that's what they want to sell the paper on, and they're not going to tell you that their effect size was 0.01 right? Because they don't want you to know that bit. So that's once you get the hang of that idea, that can be quite an interesting tool when you're reading, because you can start to go, I wonder what they really found here, right? Because you want to be able to be critical readers. You don't, just because it's published doesn't mean it's perfect, right? Editors and reviewers are not paid They do these jobs on top of everything else they do, and they make mistakes, right? Or it's meant to be a blind review, right? And I haven't done any reviewing in several years, but if I get a motor development paper that is about preschool children, I can make a pretty damn good guess where that paper came from, because there are only a certain number of people doing that research, right? So it's meant to be a blind review, but I know who wrote the paper. Well, that's a problem, because then I might overlook something that I ought to highlight as an issue, right? So again, power becomes important, because the more power I have, the better able I am to find an effect size if one exists. It might not exist, it might just be practically useless, right? Other terms you might see that are effect sizes are Cohen's D or F, eta squared, R squared. So if you see that language, you know you're looking at something that means effect sizes. Right? Again, you don't have to know the language. It's just, if you see that, you know it means this. Well, that's a good thing. That means they're reporting effect sizes. That's a plus for that article. Doesn't mean if they're not reporting effect sizes, ignore the article, because many good articles don't report effect sizes. Right? But you just want to start being more educated readers, right? Understand what you're reading a little bit better, be able to dig into it a little bit more.
Ta-da! You're funny, dude. Oh my goodness.
And they're all like, oh, thank God that's over. Who said we were going to have to do statistics on this degree? There you go. That's the limit of the statistics you have to do on this degree. Not that I agree with that, but that's currently the way the degree stands. You'd have to take a statistics class if I had my way, but I never win that fight, so... What else? What else? You wanted me to go over anobibs again. Okay. Let me turn the light on. Okay. Anobib 1 should have revised purpose statement if you need to revise it. Followed by 4 templates, and the template is on the Anobib 1 assignment. It's slightly tweaked from the one we used pre-midterm. And you're going to put all of this into one document. Okay? So just copy and paste templates onto the next page in the document and then type into them. Word limit for Anobib 1, I believe, is 275. Check the instructions to double check that number, not including your reference, right? So the actual writing bit, we're cutting down to 275, which is still way more than you'll get for any abstract for any conference that you apply for. Okay.
And so for like a message to the PDF that want to pull up, can I just
Which PDF doesn't?
Because the articles I'm getting from are from the Golden Library, but whenever I click on it, it doesn't go straight to it. So I want you to like have that trouble.
Oh, for the URL you mean? When you click on the URL, it doesn't go there?
So I could either go talk to them in the library and see.
I would do that first,
Okay.
because otherwise you're going to have to send me 900 million
I
emails.
know, no.
Or you could attach, actually the easier way to do it would be, because in the assignment you can attach more than one thing
Yeah, I could download the PDFs and just.
and attach them onto the assignment. But it'd be a lot easier if you can just get a URL that will work, a hyperlink that works directly to that paper.
I'll ask her.
Yeah. I would do that first rather than mess around with sending me the actual paper. So the reason AnnoBib 1 is in this format is because we've been using the templates before midterms to help you identify key elements to highlight in a summary. So I don't want to go from that work straight into making you write a paragraph, essay type summary, okay? So the template is slightly adjusted because some of the things I had you looking for before midterm aren't really things you would pick out in a summary. It's just I wanted you to be able to recognize them, okay? So use the new, make sure that you use the new template, not the old one. And then it follows the same idea, right? 2 rows, 2 lines per row. Don't put 3, 4, 5 lines in a row, right? Follow the format. And then when we do AnnoBib 2, you will take your verbiage out of the table and plonk it into a paragraph. Right? And then you're going to add 2 more articles. So AnnoBib 2 will be 6 summaries. These 4, unless they're terrible, and I go, do not use this, right? If you don't get that, then you're going to use this 4 and add 2 more. Okay?
So there's 4 different templates? Is that what you're saying?
No, there's 1 template, but you want 4 because you've got 4 articles to summarize.
Oh,
So this document, depending on how big your first template is, you know, how much writing you've got, you might be able to get your first template on the same page as your purpose statement. You might not. So I'm not expecting any more than 5 pages, 4 templates plus a page with your purpose statement on it. Right?
36, including the references?
No, because the reference is part of the template. Yeah,
Is it 275 per template or total?
per template, per summary, yeah. Total, that would be mean. God, even I'm not that mean. I don't think. Perhaps I am. A couple of my undergrads think I am. What else? Any other questions?
I kind of have a question. So the purpose statement, it was supposed to be like something that has like a whole. So like, you know how I did mine for like female basketball players, but there wasn't a lot of information on that. So in the conclusion, is that like going to be like, should we say this is like something about that's why there needs to be more like future research in order to find that, or you know what I'm saying? Because all my articles don't have to do with female basketball players. Like it's just like other.
Mm-hmm.
So like where would you like include that? Like the question.
You don't include it exactly. It's just if the question. So the supporting papers that you include, these 4 papers, should point to the fact that there's a hole in the current literature that your question is trying to fill. Right? So you might have 3 papers on male athletes, one of which is male basketball players, and 1 paper on female athletes who are not basketball players, right? If you've done your research correctly, then those 4 papers would indicate that there's a hole because we don't know the answer to this question on female basketball players. It's a little weak. You probably wouldn't get away with that at a PhD level, right? But at this level, that's fine. But you've got to have done your research in the databases well enough to be able to show that this question is unique.
And the purpose statement for all templates are the same? Or are we finding the purpose statement for each different article?
You'll have to find the purpose statement for each article, but that's not the same as your purpose statement. This is your purpose statement. And these are the papers you found to support the question you're asking. Does that make it clearer?
Because there's like 1 or 2 articles on my topic, is it okay to separate them so I find just outcomes on grass dominant and outcomes on just up dominant, and then I can just compare the two?
Yeah. Yeah, that's what I had to do in my work because I combined salivary cortisol in preschoolers at daycare, of which there was a lot of information, but none of it had anything to do with the relationship with physical activity. So, yeah. Anything else? I am out of town this weekend. I'm escaping to Albuquerque for the weekend. I do have some work. I have to have a lecture ready for Monday morning, so I will be in and out of Blackboard and email occasionally, but not at the normal level that I'm checking. Okay, so if you need to get hold of me, send me an email, but don't expect to hear back too quickly. Because I'm going to be playing this weekend. If you need an extension, when's the next deadline? Saturday night? If you need an extension on that, I'm not going to be grading it until Tuesday, so just email and request one.
Okay, perfect.
As I said, the reason I made it Saturday was just because I wanted to make sure you guys took a day off, right? Not because I had any intention of grading them on Sunday, right? So if you need through Monday, just ask for it, all right? But part of the trick is training you to ask for these extensions, because that's a good work skill, let alone a good school skill. Because once you're out in the workplace and they give you a deadline, if you don't meet the deadline, you lose your job. So it might be a good plan to let them know ahead of time that you're not going to make that deadline and why, so that you don't lose your job.
So you won't be here tomorrow?
I will be here tomorrow. I have class at 9 and class at 1. And then I am running home, grabbing my cat, throwing her in the car, screaming her head off, and driving to Albuquerque. She'll chill out once we get to the motorway, and we're going fast and straight. Fast and straight is okay. Curves, not so good. Corners, really bad. Stoplights, oh my God. So, anything else? So I have class at 9, I have a meeting with the dean at 10. And I have to try to upgrade my 490 papers, then I have to be back here for one.
Good luck.
It's a little crazy. It's never boring being a faculty member. I'd give it that. Boring? No.
Who was the professor that took over your supervisor?
Dr. Guerra, Richard Guerra, Guerra. He's the advisor for all of you now. Okay,
Thank you.
he's done. If you don't have any more questions.
I kind of just want to see if you could check my article. How I can change my purpose statement. So yeah, I have questions.
I'll turn the camera off for that. How's that?
Okay, yeah.